So these problems, I'm going to do 18 and 20 here. We can kind of ignore the base if the base were the same. But that's the thing, we got to get the base to be the same. There's a 4, I want to turn that into a 4 if I can, and I think I can. Because 64 is really 4 to the third power. But keep in mind that 4 to the third, which is also 64, is still raised to the x plus 2 power. Now I'm going to simplify this. This becomes 4 to the 3x plus 6. That's the exponent that I see here once everything gets simplified. Keep in mind I've got a 4 to the 5x over here. It is now that I got a common base, and I can now say that this exponent, if it's equal to this exponent, then I've got a true statement. So let's do that. Forget the base. You're not dividing by 4. You're not canceling the 4s. You're just sort of ignoring the 4s. And you're saying now 5x must equal 3x plus 6 for this statement to be true. Okay. You subtract the 3x from both sides. You get 6 is equal to 2x. Divide by 2, and you get x equals 3. Okay. So we got the common base. You can go back and plug things in. 4 to the 15th power, 64 to the 5th power. I mean, it's always a good idea maybe to have a calculator close by. 4 raised to the 15th power, big number. But it doesn't matter because 64 raised to the 3 plus 2 raised to the 5th power, it's going to be that same big number. So it's a good and easy way to kind of check things off. Here you're looking at a different base, 27 and 81. Some people are going to try and say 9 goes into both, which is true, but you can't say it's 9 to a power. But 3 to a power, yes. 3 to what power is 27? 3 to the third, to the 2x. 81 is 3 to the fourth, to the x minus 1. 3 to the fourth is 81, 3 to the third is 27. Distribute the exponents, that's 3 to the 6x equals 3 to the 4x minus, be careful, I'll see people call that 4x minus 1, 4x minus 4. You have your common bases now. You could ignore those bases and set the exponents equal to each other. 6x equals 4x minus 4. Subtract the 4x from both sides. It's kind of the same problem we just did. 2x equals negative 2. 2x equals negative 4. Divide by 2, you get x equals negative 2. You can kind of go back and plug it in and do the same thing we did earlier.